19.5 Day 2 Angle Relationships in Circles. Content Standard. Identify and describe relationships among inscribed angles, radii, and chords. Language objective. Explain to a partner how to find the measure of an angle formed by intersecting chords if the measure of the intersecting arcs are known. Okay, so here is another theorem. This is for tangent, secant, exterior angle. Right, so here we're looking for exterior. In the previous day, we're looking for interior. So we're saying that if a tangent and a secant, two secants or two tangent intersect in the exterior of a circle, then the measure of the angle formed is half the difference of the measure of intersecting arcs. Okay, notice that in day one the angle is the sum, but now it's the difference, so this is subtracting, right? So here we're saying that angle 1 is 1/2 of the difference of the arc from A to D minus the arc from B to D. And similarly, if we have two tangent, so angle 2 is equal to 1/2 of the arc EHG minus the arc EG. And if we have two secant, angle 3 is half of the arc from J to N minus the arc from K to M. Right, so let's go through this example. Example 1, we're solving for x. So here we have angle L is 25, and we need to solve for x. So we can say that is 25 equal to 1/2 of 83 minus x. So bring the half over, so 50 equal to 83 minus x. Subtract 83 from both sides. So then we have a negative 33 equal to negative x, and divide by negative, so 33 degree give us our x. Right, and for part B, well, first we need to solve for this arc first. Notice that for the circle, the total degree is 360. So to solve for this part, we take 360 minus 238. So this is 122. So then we say that angle x equal to 1/2 of 238 minus 122. So then x is 58 degrees. Right? Okay, so solve for x. So to set this up, we said x equal to 1/2 of 161 minus 67. Okay, so x is 47 degrees. Right? Okay, number 9 says that the superior oblique and inferior oblique are two muscles that help control eye movement. They intersect behind the eye to create an angle, shown as shown. If the measured angle AE, the major arc AEB is 225, so we're looking for AEB, so this is 225. And to solve for this part, we take 360 minus 225. So this is 135 degrees, so we are to solve for the angle ACB. So we're looking for this, so we'll call that x. So we say that x equal to 1/2 of 225 minus 135. Okay, so then x is 45 degrees. To say that you can summarize angle relationship in circle by looking at where the vertex of the angle lies. on the circle, inside the circle, or outside of the circle. Okay, so here is a summary of it. If it's on the circle, so then this angle 1 is half of this, right? Okay. And if it's on the circle, this angle 2 is also half of that. And if it's inside the circle, then angle 1 is 1/2 of 86 plus 44. And if it's outside of the circle, then it's the different. Okay? So think, okay, an easy way to think is that if inside the circle we use the product, and if outside the circle we use the difference. Right, okay, so let's go through some more examples. So for part A, we're starting for the arc from F to D. So we're looking for the arc from F to D is this part here. Okay, notice that this, we're using this, so this forms the angle here, right? So let me see that this is 50 equal to 1/2 of 150 minus the arc FD. So bring it, so then this is 100 equal to 150 minus FD. So bring over, so negative 50 equal to negative the arc from FD. So then the arc from F to D equal to 50 degrees. Right? Okay, now let's find, we're looking for the arc from C to D. So from C to D, we're looking for this part here. Okay, well, we were given that this is 50, so we need to find out what this angle here is. But we don't know that angle yet, right? But then we can solve for this angle to find out that. So we say that this angle X is equal to 1/2 of, okay, it's 1/2 of 64, and we notice from F to D from here, we say that is 50. So 64 plus 50, and half of that is 57 degrees. So we know that this angle here is now 57 degrees, but this forms a straight line, so then we can find this angle by doing 180 minus 57. So we know that this angle here now is 123. So now we can use that to solve for our from C to D, right? So we say that is 123 equal to 1/2 of 150 plus CD. So bring it over, so 123 times 2 is 246 equal to 150 plus CD. Subtract 150. So then 96 degrees equal to the arc from C to D. Okay. Right, okay, let's solve for Kn. So we're looking for the arc from K to N. So we're looking for this arc here, right? So first we need to find out dimension for this arc first. Okay, my mistake. We don't need to solve it. I just see there's an easy way to do this. So first we need to find out this angle here first. So in this form a straight line. So we take, so this angle is 180 minus 79. Okay, so then that angle is 101. So this angle, so then you write this is 101. So to solve for, okay, notice that this form here, so we can solve for K to N, so call this part X. So we say 101 equal to 1/2 of X plus 86. So times that. So So it will be 202 equal to x plus 86. Subtract 86 from both sides. So it will be 116 give us our x in terms of degree. So then that's the measurement from k to n. Right. Okay, so let's try these. So to determine the value of x. Okay, notice that for the circle is always 360 degrees. So to solve for this, we take 360 minus 116. So this gives us 244. Right? So we said x is 1/2 of 244 minus 116. Okay, so x is 64 degrees. And similarly, we can do 6, so then x is equal to 1/2 of 173 minus 79. So x is 47 degrees. Right. And number 7, we work out the same way, so then this is 1/2 of 113 minus 23. So x is 45 degrees. Right? Okay, and for number 8, we need to do some work, right? But we're given a hint. Notice that this passed through the circle, through the center of the circle. So we know that through the center, the circle is semicircle, so 180 degrees, and this is also 180 degrees. So we're given that this is 148 already, so 180 minus 148. This gives us 32 degrees. Right? So we say that 12 degrees equal to 1/2 of 32 minus x. So bring the half over. So we have 24 equal to 32 minus x. So subtract 32 from both sides. So give us -8 equal to -x. So then 8 degrees equal to x. Okay, so here doing the same thing, we're solving for the distance from y to z. Okay, so this is y to z, but notice that we're not giving any measurement here, right? So when we can call this part x. Well, notice that the same thing for the whole circle is 360 degrees, right? So this is 360 minus x. Okay, so let's work out number 9, right? So we can say that 60 degrees equal to 1/2 of 360 minus x minus another x. Right, so then this is 120 equal to 360 minus 2x. So 120 minus 360 give us a negative 240 equal to negative 2x divided by 2. So then x is equal to 120 degrees, which is the same as we call that our yz. So 120 degrees. Right. Okay, so we can use the same technique for number 10. So call this x. So this is 360 minus x. So we're given that 100 degrees equal to 1/2 360 minus x minus another x. So this gives us 200 equal to 360 minus 2x. So negative 160 equal to negative 2x. So then 80 degrees is from D to E. Right, so that's the end of our notes on 15.5 day 2. Your assignment is number 4 through 12, even in your textbook. and you also need to finish your HRW and turn them in, right? Okay, and the last page is the summary of all of module 19. So you guys can print this out, or I'll load this up on your Google Classroom, and you can print out a worksheet of this. Okay.